Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last few videos we've been writing some neighbor finding code. We wrote one that does brute force and one that uses grids, but we haven't tested either of these, and so it's time for us to write some tests. So we have our brute force neighbor finder and we have our grid neighbor finder, and we should put inside of our test code here a new class for test neighbor finder. Okay, let's go ahead and let's copy out the imports from one of our other tests, and I'm going to pull in everything here. So how do we want to make this work? I kind of need to run the same tests on the brute force neighbor finder and the grid neighbor finder, and we're going to write some other neighbor finders as well. I don't want to have to copy and paste this code, so what I'd kind of like to have is the ability to write a function that I can call with whatever neighbor finder I want. So a simple way to do this would be, so let's def test no neighbors, and for all of these I'm going to pass in a neighbor finder GHBOR finder. What are we? Oh, it takes type parameter. This will be a neighbor finder on array of double. Okay. And that way we'll just do everything. Notice I'm not putting an @test annotation here because all of our tests need to have no parameters for them. So my @test will be a def test brute force no neighbors, and what this is going to do is it's going to call no neighbors with a new brute force neighbor finder, and when we construct one of these we have to pass it how many dimensions we're going to do as well as the set of points. I'm going to do my tests here in 2 dimensions, though for the brute force it would be good to have some that went above that. And I guess the simplest test that I could do would be to have a sequence that's empty. Let's see, what does this want here? Oh, this wants a something that is, it needs the type sequence of array of double empty. What is this unhappy about? And required, oh, index sequence. In fact, just to test this, question is, could we say just index sequence? There we can, because it can figure out from the type over here that it needs to be an index sequence of whatever our type A is on this, and because we're passing this into a neighbor finder of array of doubles, it can figure out that this has to be creating an array of doubles. So we can Okay, the way that this is going to have to work, we're going to call on our neighbor finder dot visit neighbors. I'm supposed to pass it an array of doubles, which will be 2 doubles, a search distance 1, and a visit function. Okay, now this is where things get potentially interesting for us, is that this needs to do something that then I can check inside of my test. So one possible way of doing this would be to just count how many there are and make it so that this is a function of A goes to count plus equals 1. Now, because there should be nothing that matches this, we should be able to assert that 0 is equal to count. And if I run this test, we get a green bar. Okay, but of course that wasn't a very interesting test. I should also so we'll test one neighbor, which I then need to write. Okay, and we're expecting this to come back with 1. And in fact, actually, now that I think about it, I can write another more interesting test. So right now I'm searching for these things against 0, 0 with the search distance of 1. Copy, paste. I can do a no neighbors 2 where I actually have data in here. It's just none of them are close enough. And then the test brute force with one neighbor, I am going to say array of minus 0.5, comma 0.5, comma array of 4, comma 3. Only one of these should match, and indeed it would be nice if I make a second test like this, where I will put in front of here array of 6, comma 2, just to make sure that I don't have some weird thing where the first element is somehow special. And we ran 4 tests and they all passed. Okay, these aren't particularly high quality tests in here, but they will serve our purposes. Okay, so what about for our grid? So theoretically, I should be able to copy all of these I need to change their names. And then change the names here. And of course, this is introducing some errors that we'll have to go back and fix. The error is because the grid only works in 2 dimensions, so I don't have to pass that in. And what happens if we run this? Boom. This says it's not happy. It passed 7 of the 8 tests, but it didn't like this one. It didn't like the test no neighbors. And so the question is, why? What happened here? Well, let's go over, pull this up, unsupported operation empty.min. So if we look at the last code that happened in here, we went through and we calculated a minimum value, which is supposed to be called on a collection. This is not well defined for an empty collection. And indeed, that's a bit of a problem for us here, is that if this collection is empty, well, what do we do for all of this? First off, if the collection happens to be empty, then a lot of these things become much simpler. First off, let's go with just a call to non-empty. Then we do this. Okay, they like to use a different formatting for the for loop, and I'm fine with that. But our error up here was caused by the fact that we can't do min or max. So if excess dot is empty, okay, so this is still going to be a nice double, but I want to do this basically for all of these, and if it's empty, that won't wind up happening. And now we pass all 8 of our tests. Okay, this is still not very robust. It would be very nice to have some more tests where we have a large number of points and we make sure that enough of them are close by. But I'm not going to take the time in this video to write those tests. That remains as an exercise for the viewer. We'll come back in the next video and we'll see what the limitations are for grids, and we'll talk about how we can get around